Hi, everyone. I'm Steph.
And I'm Lisa.
And together we're PD Connect. Thanks for joining us. We have Dr. Lustig here today. I'm going to intro him and then he'll take the floor. Robert H. Lustig, MD, MSL, is Emeritus Professor of Pediatrics in the Division of Endocrinology and member of the Institute for Health Policy Studies at UCSF. Dr. Lustig is a neuroendocrinologist with expertise in metabolism, obesity, and nutrition. He is one of the leaders of the current anti-sugar movement that is changing the food industry. He has dedicated his retirement from clinical medicine to help to fix the food supply any way he can, to reduce human suffering and to salvage the environment. Dr. Lustig graduated from MIT in 1976 and received his MD from Cornell University Medical College in 1980. He also received his Master's of Study in Law degree at the University of California, Hastings College of the Law in 2013. He is the author of the popular books Fat Chance, The Hacking of the American Mind, and Metabolical, The Lure and Lies of Processed Food, Nutrition, and Modern Medicine. Thank you so much for joining us. And Lisa, well done as lifting up the books. We can't wait to hear what you have to say. Thanks for joining us.
We are extremely honored to have you.
Yes.
Thank you.
Well, thank you. And I very much appreciate the invite. I swear I did not put them up to that. But at the same time, if you have interest in this topic, both those books will do very well. Actually, the book that might even be best for this audience, for a Parkinson's disease support group and NGO, would actually be The Hacking of the American Mind, the middle book, which was published in 2017, because it talks about diet and mental health, very specifically addiction, depression, and obviously PD goes, with a lot of that. So as I'm sure you know, if you overdo dopamine, you get addictive behaviors. This was first noticed by Oliver Sacks back when he started treating his Parkinson's patients with L-Dopa. So there's there's a lot to be learned, and hopefully this talk will make some of that even more clear. So with that, let me go ahead and share my screen, and let's get started. So yes, the name of the book, the most recent book, is Metabolical, and that obviously is a portmanteau of metabolic, the workings of the body, and diabolical, which is the workings of big food, big pharma, and big government. And very specifically, we will talk about the food side more than the politics side in this talk, but maybe someday you'll have me back and we can discuss all the dirt, in terms of how we got here and why this is such a big nut to crack and so difficult to manage. In any case, the primary problem that we're going to talk about today is over here on the left, this disaccharide. Okay, this is called sucrose, or table sugar, or cane sugar, beet sugar, the stuff you put in your coffee, the little crystals, okay? And you will notice that it is two molecules in one, okay? This one here is a 6-membered ring, and this one over here is a 5-membered ring. They are not the same. This one is called glucose. You've heard of that, like measuring your blood glucose, okay? Same thing. And this one over here is called fructose. And that is not the same thing. This is a very different compound and is metabolized completely differently from glucose. When you consume sugar, you're consuming both. And the glucose is not great, but not terrible. For lack of a better word, it's reasonably safe. The fructose, on the other hand, is a major problem. And it is now been shown to be the driver behind virtually every and all chronic disease that we have. Type 2 diabetes, hypertension, dyslipidemia, cardiovascular disease, cancer, dementia, fatty liver disease, polycystic ovarian disease. Now, the question is, does it cause Parkinson's? And the answer is, I don't know that. I don't know that. It does cause other mental health disorders, and it does cause dementia, and Parkinson's disease is associated with dementia in many cases. So we're going to talk about sugar. We're going to talk about junk food. We're going to talk about how those are related to mental health and cognitive decline. But I'm not here to tell you that sugar is the cause of Parkinson's disease, because I do not know that. I'll do my best to, make causation and correlation clear as we go. But ultimately, what we have learned, and I will close with this at the end, so I'm showing it to you at the beginning, but we're going to show you at the end. Ultimately, for a food to be healthy, it has to do three things. It has to feed the gut, you'll see why, protect the liver, you'll see why, and support the brain. Any food that does all three is healthy. Any food that does none of the three is poison. And any food that does one or two, but not all three, is somewhere in the middle. And unfortunately, sugar does none of the three. And you will see that sugar is, in fact, not a food. Rather, it is a consumable poison. So let's go ahead and start. And there's going to be a fair amount of science, but I'll do my best. Let's start with something easy. Here are the 10 most obese states in the nation. Okay, I used to live in Memphis, Tennessee, and I got to tell you, it was pretty bad. Here are the 10 laziest states in the nation. I don't know what's going on over there in Nevada. I guess you can only, burn so much energy, going like this. Here are the 10 most unhappy states in the nation. Wonder why. Here's the diabetes rate. Here's the heart disease rate. Here's the Alzheimer's disease rate, relatively important with relation to Parkinson's. Here's the opioid use rate. Here's the depression rate. And finally, here's soda per capita consumption. Now, what do you see? You see correlation. Now, correlation is not causation. Now, is it that consumption of soda causes obesity, laziness, unhappiness, diabetes, heart disease, Alzheimer's, opioid use, and depression? Or do obese, lazy, unhappy people with diabetes, heart disease, Alzheimer's, opioids, and depression bury their sorrows in a can of Coca-Cola? You can't tell. There's no way to determine causation from a snapshot in time. All we can say is that there's some association, and indeed there is. So the question is, what does that association look like? And can we get any further toward causation with other data? So here's what we know. We know that ultra-processed food correlates with depression. As you can see here, ultra-processed food consumption increases the hazard-risk ratio for depression. And we know that ultra-processed food consumption also correlates with reductions in cognitive abilities in older adults. So here are 4 different measures of cognitive decline. And you can see that as ultra-processed food goes up, these 4 go down. Ultra-processed food also correlates with dementia, as you can see here. All right, more ultra-processed food, more dementia. Now, very wide standard deviations, very wide splay. So not everybody, but nonetheless, a very clear increase. And you could say, well, there are a lot of confounders like poverty and education level and alcohol use and what have you. And that's all true. Those are confounders. But when you take the confounders into account and adjust for the confounders, the effect is still there. As you can see, it is not crossing the identity line. So there is an effect of ultra-processed food on dementia. Now, I'm here to tell you that here's the way to think about this problem. Okay? Sugar is the payload. It is the poison. And ultra-processed food is the vehicle. It's the delivery system. Okay? In the same way that nicotine is the payload and cigarettes are the vehicle, well, sugar is the payload and ultra-processed food's the vehicle. Now, what data do we have on sugar and neurologic disease. Does sugar cause dementia? Well, we don't know that for sure yet. We do know that sugar is associated with dementia, but causation is obviously much harder to prove. So here's what we do know. We know that obesity is associated with dementia. We know that obesity is associated with altered neural projections in the brain that are consistent with dementia. We know that sugar generates this phenomenon in the liver called insulin resistance, which leads to hyperinsulinemia. And we know that insulin resistance and hyperinsulinemia are associated with dementia. So maybe this is an intermediate between sugar and dementia. We know that consumption of the Western diet correlates with dementia. I just showed you that. And here's a piece of, experimental data that might be useful. In animals, in rats, you can give them fat or sugar, and it will cause obesity, but only sugar caused cognitive decline. Now, that's very interesting. Okay, fat did not cause cognitive decline. In fact, fat actually improved cognition, but sugar caused cognitive decline. So in animals, we have data that's actually causative. But in humans, we only have associative data. We only have correlative data. We don't have causative data. And so that remains a big question. So now that we've got that out of the way, what might be the reason for sugar causing problems? Well, I'm here to tell you that sugar damages your mitochondria. And very specifically, it damages this enzyme here. This enzyme is the fuel gauge on the liver cell and the brain cell and virtually every other cell in your body. This is the enzyme that tells your cells whether or not there's enough energy to burn. It's called AMP kinase. Now, AMP kinase, when it goes up, it tells your cell, not enough energy, need more. Okay, that's what it tells it. And so it makes more mitochondria, and it makes those mitochondria fresher and work better, all good. So AMP kinase is a good guy in the story. But when AMP kinase goes down, then your cell doesn't know whether or not the fuel tank is empty or full. And that's kind of what happens here. And we now know that, for the most part, dementia, Alzheimer's disease, is a metabolic disease. And we've learned that over the last, I would say, 5 years. Now, what does sugar do? Well, it alters mitochondrial function where that AMP kinase is. So this is a study that we did in children, not adults, but in children. But there are studies in adults that look exactly like this. What we did was we gave 43 kids in our obesity program at UCSF who had metabolic syndrome, who had, metabolic dysfunction due to obesity. And what we did was we took the sugar out of their diet. So this is what they looked like at baseline. Their triglycerides were high, their livers were making lots of fat. Notice the color, okay? And it was showing up in the blood as serum triglyceride, or VLDL, very low density lipoproteins. What we did was we took the sugar out of their diet and we substituted something that was equicaloric, something that would not let them lose weight. We gave them extra starch. So in the vernacular, we took the pastries out, we put the bagels in. We took the sweetened yogurt out, we put the baked potato chips in. We took the chicken teriyaki out, we put the turkey hot dogs in. So we didn't give them good food. Excuse me. We gave them lousy food. We gave them crappy food. We gave them processed food. We gave them kid food, food kids would eat. But it was no added sugar food. We took their added sugar from 28% of calories down to 10% of calories. Now, if you do that, you're going to lose weight. We didn't want them to lose weight, because if they lost weight, people would say, well, of course they got better, they lost weight. We wanted them to stay the same weight. So we had to give them equal amounts of starch, right? And then we did that for 10 days, and then we studied them again. What we noticed was their liver fat went down 22%. Their turning sugar into fat, called de novo lipogenesis, went down 46%. Their serum triglycerides went down 49%. Their visceral fat, their big belly fat, went down 7%. All good. All these things are good. And most importantly, their pancreases started making insulin properly. We reversed their metabolic dysfunction with no change in calories and no change in weight, just by taking the sugar out and putting the starch in. Can you imagine how much better they would have got if we hadn't put the starch in? Now, if you actually go into the cells in the liver or in the brain, and you look at what's happening, which is what Ron Kahn at Joslin Diabetes Center did, what they showed was that the mitochondria here respond to these two molecules completely differently. Here's glucose, here's fructose. You'll notice glucose is in green on purpose because glucose acts like a green light and actually increases mitochondrial function, increases mitochondrial beta oxidation. That's what mitochondria is supposed to do, is burn fat and burn carbohydrate, beta oxidation, good thing. And it does it by activating AMP kinase and also activating this other enzyme here, HADH, called hydroxyacyl-CoA dehydrogenase. So glucose, for lack of a better word, is good. Fructose, on the other hand, notice in red, lowers beta oxidation. And the reason is because fructose interferes with three enzymes that are necessary for mitochondria to function properly. One is AMP kinase, one is this other one here called ACAD-L, acyl-CoA dehydrogenase long chain, and the last one here is CPT1A, carnitine palmitoyl transferase 1A, the sum total of which causes mitochondria to work less well, inhibiting beta oxidation. So glucose, fostering beta oxidation, fructose, inhibiting beta oxidation. So Ron Kahn himself said about this, the most important takeaway of the study is that high fructose in the diet is bad. It's not bad because it's more calories, but because it has effects on liver metabolism to make it worse at burning fat. As a result, adding fructose to the diet makes the liver store more fat, and this is bad for the liver and bad for whole body metabolism. Exactly right. I agree. Why? Well, this goes to that AMP kinase. When you consume fructose, you end up making a lot of this byproduct here called methylglyoxal. And methylglyoxal can fit in the active site of the AMP kinase and bind to one of these arginines here. And in the process, render that enzyme inactive. You're basically poisoning your mitochondria. And we know that that's true because we measured the byproduct of this methylglyoxal called D-lactate. And we showed that in obese people, D-lactate was way higher. And we also showed that when we got the sugar out of kids' diets, the D-lactate fell by 38%. Well, that's one way that fructose is bad, by inhibiting the mitochondria. And mitochondria are the energy burning factories inside each of our cells, especially our brains. And the brain is, as you know, the biggest mitochondrial storehouse of all, because neurons cost a lot of energy to run. So there are a lot of mitochondria in neurons, and you're poisoning them. Now, there's another way that fructose might be inhibiting brain function, and that is by inhibiting the conversion of this amino acid, this excitatory neurotransmitter glutamate, to this inhibitory neurotransmitter called GABA, gamma-aminobutyric acid. Now, this is a complicated slide. I only want to point out one thing. Okay, what I want you to see is that glutamate, which you get in the diet, gets converted to glutamine, and then that glutamine gets converted to GABA. Okay, so glutamate to glutamine to GABA. And there's an enzyme that converts glutamate to glutamine, and it is called glutamine synthase. Well, it turns out glutamine synthase here, GS, okay, is necessary to turn glutamate into glutamine, and then that glutamine goes across into another neuron where it gets converted to GABA. So there's a cycle of glutamate to GABA, and this glutamine synthase regulates it. Well, it turns out glutamine synthase is inhibited by fructose. Fructose actually blocks this enzyme from working. And so you end up with a lot of glutamate and very little GABA. So you can see that actually in the brains of people. So this is in humans. You give them glucose IV, it looks like this. You give them fructose IV, it looks like this. Clearly not the same. You give them together, it looks like this. And this is what's going on in the brain of a human, as you'll notice. Both. Even though they didn't get fructose, you've got both. And what we see is if you take the nerve terminals, the synaptosomes, where the nerve terminals are, and you incubate them with glucose, here's how much glutamate, here's how much GABA. So a normal ratio of glutamate to GABA is about 3 to 1, 1500 to 500 or 3 to 1. But if you incubate those nerve terminals with fructose instead, now it's 2500 to 50, basically is like 1000 to 1. Okay, so you are inhibiting the conversion of glutamate to GABA with this compound called fructose. This is not good. And in certain states like pregnancy, fructose in the brain goes up. You see this cerebrospinal fluid to plasma ratio goes up. And so this is something that can be made in the brain, even from glucose. So if you consume it, it's even worse. Now, here's something important for dementia. We all know that patients who are exhibiting cognitive decline show altered reaction time. They reduce their reaction time to like driving a car and hitting the brake, etc. Okay. Now, we know that reaction time is related to BMI, but it's a very messy correlation. But if you look at the reaction time, you'll notice that the thing that makes more sense is whether, obviously if you're old, the reaction time is higher. If you're young, reaction time is lower. But the BMI clearly plays a role. But it turns out there's something that plays the role more, and that's inflammation. So IL-6 or interleukin-6 is an inflammatory cytokine that's associated with obesity, associated with high BMI. And it turns out that when you actually look at BMI or IL-6 against reaction time, it's the IL-6 that makes the difference, and even more so than the age. So inflammation in the brain leads to altered reaction time. And so the question is, how does that inflammation in the brain occur? And is it age-related? And the answer is, it's only partly age-related. You can actually stop it. The thing that makes it happen is, guess what? Sugar. Okay? So diet and exercise alter mitochondrial function. Mitochondria throw off these reactive oxygen species. This is inflammation. You got to get rid of these. If you get rid of these, you can improve your cognition. But if you don't get rid of them, then cognition goes down. And also synaptic plasticity goes down. Trophic factors helping mitochondrial function go down. In other words, you've got to get the inflammation down. So fructose alters that phenomenon. It increases insulin. It changes mitochondrial function. And the thing that can make that better is, of course, getting the sugar out of the diet, but also omega-3 fatty acids. They help this process. And omega-3s are associated with dementia in a negative way. In other words, higher omega-3s, less dementia, lower omega-3s, greater dementia. And omega-3s also help neurons stay alive through this process called membrane fluidity. So it could be that fructose is damaging the brain. It's damaging this glutamine synthase. It's causing increased glutamate, which is an excitatory and toxic neurotransmitter, and making less GABA, which is an inhibitory and protective neurotransmitter. And finally, there's the possibility that the microbiome, that is the GI tract, might actually play a role in dementia as well. Now, you're familiar with the fact that your intestine is a sewer, okay? It's got all sorts of sludge running through it. It's got bacteria. It's got lipopolysaccharides. It's got cytokines, all this bad stuff that you poop out, right? Well, the goal is to keep it from getting into the bloodstream. And there are three ways the intestine keeps the bad stuff out. Number one, there is this mucin layer, this mechanical mucin layer between the bacteria and the blood. Second, there is this biochemical barrier called tight junctions. These are proteins that, where the pores are, they prevent stuff from getting across and through, so that they don't end up in the bloodstream. And then the third way is an immunological barrier, which is not pictured on this slide, but there are a bunch of cells called Th17 cells that act like an immunologic barrier. As long as these three barriers are intact, physical, biochemical, and immunologic, the sewage stays in the sewer and doesn't enter the house, okay? But when it enters the house, it goes straight to the liver, causes insulin resistance, which causes hyperinsulinemia, causes stuff to go to the brain, which can foster dementia. Now, what we know is that fructose, this bad molecule, this problem molecule, actually causes those tight junction proteins to not function well, causes leaky gut, causes the translocation of those, all that, the bacteria, the lipopolysaccharides, the cytokines from the gut into the bloodstream. And then those go to the, via the portal system to the liver and cause insulin resistance at the level of the liver. In addition, the fructose goes to the liver and actually does it directly too. So it can do it at the gut and it can do it at the liver. And it changes the gut microbiome. So just read this one sentence. Okay, that associated with fructose seemed to hold more potential to induce host metabolic disturbances compared to glucose, mainly by promoting bile acid deconjugation and taurine release. And taurine is a osmolyte that changes permeability and compromises intestinal barrier integrity, which is exactly what you don't want to do. Oops, sorry. Do that again. Okay, and here's that immunologic barrier that I was mentioning, this Th17 barrier. Now, in a regular diet, these IL-17 cells, these IL-17 molecules, which are made by the Th17 cells, they're basically keeping that barrier intact. And so the bacteria can't get in, the fat is not a problem. But if you go on a high-fat diet, so a ketogenic diet or an Atkins-like diet, you'll notice that the barrier stays intact and the Th17 cells are still there and the IL-17 is still there. So yes, more fat will get through, but the bad guys stay in the intestine. But when you do a Western-style diet, which has both high fat and high sugar, now what happens is you deplete those Th17 cells. You end up with more Th1 cells. They're not making the IL-17. Lots of fat gets across, and bad guys start to enter the bloodstream. So it is the combination of the fat and the sugar that seems to be the biggest problem with that immunologic barrier. And finally, what clinical data do we have? Well, this is data in humans. Long-term overconsumption of sugar starting in adolescence produces persistent hyperactivity and neurocognitive deficits in adulthood. That's worrisome. My colleague, Dr. Bill Wilson, who is a private practitioner in Lowell, Massachusetts, he's a very astute clinician, and he's done a lot of work over the years looking at metabolic illness. He has identified 22, count them, 22 different symptoms that all go together. And he noted that when he takes people off sugar and gets them on a low-carb diet, these 22 symptoms all get better altogether. And so he has named them carbohydrate-associated reversible brain syndrome, or CARB syndrome. How appropriate. And you just read through them, okay? And I think you'll recognize many of them. You've probably had them yourselves at some point or other, okay? And so if you have any of these, you might try 1 week of a low-carb diet and see how you feel. And if you feel better, there's a reasonable good chance you have CARB syndrome, because this is pretty darn common. And a lot of people have it. We can actually see signs of this in the brain because we can see changes in brain thickness, especially in the area of the brain that controls emotion, called the prefrontal cortex. This is the executive function part of the brain. So this is basically putting the damper on the reward center. It's putting a damper on the hate center. It's basically your reasoning part of the brain. And what you can see is that from the top, bottom, left side, right side, this area is thinned with obesity. And it also correlates with reduced executive function in the same area. We know that in teenagers, this is teenagers now, who have metabolic syndrome, they have less brain tissue, okay? They have more cerebrospinal fluid, and they have lower hippocampal volume. As their insulin resistance gets worse, their hippocampal volume goes down, okay? And their CSF goes up. So basically, the areas of the brain that are controlling emotion and memory and cognition are actually going down in teenagers. And that results in changes in behavior, like executive function. Here's the p-value going down. Cognitive flexibility, here's the p-value going down, just because of metabolic syndrome. And of course, sugar is a primary driver of metabolic syndrome. It's not the only one, but it's a big one. This is a study, epidemiologic study, agreed. This is not proof. This is not causation, okay? But more sugary beverage consumption, more cognitive decline, more preclinical Alzheimer's disease in the community. So sugar beverages, more Alzheimer's. So here's what's happened to our diet. Here's sugar consumption here on the y-axis. Here's the year starting in 1820, so 200 years ago, and going up to current, okay? And you can see that our consumption of sugar has increased 25-fold. We used to get about 5 pounds of sugar a year, getting the fruits and vegetables, the occasional honey. Here's the advent of C&H and Domino and Texas, Louisiana, Hawaii, during the 19th century. Here's stabilization when you could only buy sugar in 5-pound bags at the grocery store. Here's the rationing of World War II and the reduction in sugar consumption during that period of time. And then you'll notice it came back up to the same level. And here's the advent of ultra-processed food here in the mid-1960s. And here's when we substituted high fructose corn syrup for sucrose because it was cheaper. And here's when the dietary guidelines told us eat less fat. Okay, and you can see went back up again. Okay, and basically, this is a 25-fold increase in a toxic substance in our diet. What I've now done is I've overlaid on this slide the percent of gross domestic product, GDP, spent on US healthcare for the same period of time. So in the mid-1960s, that's when our healthcare costs started to go through the roof. And they've been rising ever since. And they are now at 20% of all expenditures. And the reason is because our diet sucks. And all you have to do is look at all of the mental and neurological health problems that continue to increase without any end in response to our ultra-processed food diet. So we have to do 3 things. We have to change our food to do 3 things. We have to protect the liver so that metabolism gets better. We have to hydrate appropriately. We have to reduce environmental toxins like lead and cadmium. We have to reduce the glycemic load, which is refined carbohydrate. But most importantly, we have to get rid of the sugar. Number two, we have to feed the gut. Now, remember, we have to feed the microbiome. We have to feed the bacteria in the gut, or they will feed on you. How do you do that? Well, you do it with soluble and insoluble fiber. That's the food for the bacteria. But we've taken it out because you can't freeze fiber. I'll prove it to you. Take an orange, put it in your freezer overnight, take it out the next morning, put it on the counter, let it thaw, try to eat it, see what you get. You get mush. Why do you get mush? Because the ice crystals macerate the cell wall, let all the water rush in. Well, hey, food industry knows that. So what do? They squeeze it and freeze it. Lasts forever. Now you've turned a food, an orange, into a commodity, frozen concentrated orange juice. You could sell it on the commodities exchange. It will last forever. You can sell it around the world. You can make lots of money because there's no depreciation. Good for your bank account, bad for you. Okay. We have to reduce processed carbohydrates for all the reasons I showed you in terms of that microbiome and that bacteria, that barrier. We have to increase whole intact food that has a cellular matrix so that the sugar doesn't just leach out immediately. We have to provide prebiotic nourishment, that's dietary fiber. We have to replace probiotic nourishment, that's the gut microbiota. And the way to do it, get rid of the sugar. And finally, number three, we have to support the brain. How do you do that? Well, nutrient-dense foods that don't have cadmium and lead in them. Okay, brain-selective nutrients like zinc and selenium. Okay, brain essential fats like omega-3s. You need EPA and DHA. Okay, and you only get those in marine life. You only get those in wild fish, not in farmed fish. You need healthy proteins that provide sufficient and appropriate amino acids like tryptophan, which is the precursor to serotonin. It's the rarest amino acid, and it's really found in eggs, chicken, and fish, not exactly processed food. We need brain-selective nutrients that have vitamins, especially B vitamins, because those help govern neurotransmitter function. Those are important for clearing toxins out of the brain that we didn't even talk about. And how do you do that? Well, get rid of the sugar. So people will tell you that food is medicine. Food can be medicine. It's true. Food can be medicine, but food can also be poison. Okay. And the question is, what distinguishes these two? And the thing that distinguishes these two are the three items that I just discussed. Protect the liver, feed the gut, support the brain. If they do those three things, then food is medicine. If they don't do those three things, then food is poison. And sugar starves the gut, floods the liver, and damages the brain. Sugar is not food. Sugar is a consumable poison. There are other consumable poisons. Hemlock is a consumable poison. Belladonna is a consumable poison. There are a lot of things that, you know, the food industry doesn't put into food because they know it's poison. Well, but sugar is the one you like. Sugar is the one that's addictive. Sugar is the one they put in there very specifically because they know when they add it, you buy more. And we know that sugar is correlated, if not causative, we know it's correlated with virtually every neurologic and neurodegenerative disease. So it will not surprise me if in the future that we find out that sugar is at least correlated with, if not causative, for Parkinson's. But it is certainly associated with dementia, addiction, depression, and cognitive decline, and many, many other neurologic conditions. So with that, I will stop sharing, and I'll be happy to entertain any questions.
All right. Well, wow. Thank you so much, Dr. Lustig. That was a lot.
Yeah, it was a lot. I know it's a lot.
But good info, really good info.
Well, I mean, I could have made it super easy, but then you wouldn't have believed me.
Good point. Good. Well, we do have some questions here in the chat. We'll start from the top if you still have time. Okay, let's see. From the top. Okay, here we go. Is fruit a source of fructose?
Right. So everyone wants to know about fruit. Okay. Yes, fruit is a source of fructose. That's why it's fruit. That's why fructose is called fruit sugar, because it was isolated from fruit. And the chemical, the molecule is exactly the same. There's nothing different about the fructose in the crystals versus the fructose in the fruit. They're the same. The difference is dose, because most fruit doesn't really have that much fructose. It's sweet without having to have much sugar, especially berries. Berries are actually not that high in fructose. And number two, the most important thing is fruit has fiber. The fiber is necessary to prevent early absorption of that fructose in the gut. And in doing so, by preventing early absorption, you're protecting your liver, and it goes further down the intestine where the gut microbiome will chew it up for its purposes. In other words, you are feeding the gut. So you're protecting the liver and feeding the gut, and you are not getting it absorbed because the gut's chewing it up instead. So even though you consumed it, you didn't get it. That's another reason a calorie is not a calorie, because if you consumed it with its requisite fiber, there's a good chance your bacteria got it, you didn't. Whereas if you consumed it without the fiber, like orange juice, then you did get it. And then it flooded your liver, starved your gut, and potentially hurt your brain.
Yikes. Okay, good answer. Okay. Is food with added cane sugar bad?
Yes.
Yes.
The question is, why was the sugar added? And the answer is because the food industry knows when they add it, you buy more. They learned this during the 1970s and 80s. When we went low fat in 1977, due to the first USDA dietary guidelines, the food industry said, well, how are we going to make all this food palatable? Because the fat, flavor was in the fat. Okay. You take the fat out, the food tastes like cardboard. But they learned that if they added sugar, we bought it anyway. We bought more. And the more sugar they added, the more we bought. And they kept upping and upping and upping the amount. Okay. And yes, you can make dog poop taste good with enough. And they do.
Oh, man.
And they learned it was addictive. And just because something's addictive doesn't make it bad for you. Caffeine's addictive. And caffeine, people argue whether caffeine is bad for you. All the data actually shows that caffeine is good for you. So just because something's addictive doesn't make it bad for you. But sugar is not just addictive, it's toxic too. And that's a different story. Things that are both toxic and addictive, we keep out of the hands of children and we regulate, like tobacco, alcohol, opioids. Things that are toxic and addictive, we don't let children have. But sugar, we not only hand it to them, we call it love. And all you grandmas out there, you're really just drug pushers.
Oy.
Oy.
Wow. Well, I'm not a grandma, but
well, think about it.
That's so true when you think of it that way. Oh man. Okay. Well, this is a two-part question and you've answered a bit of it, but are vegetables and fruit included in a low carb diet? What is not?
Oh,
and are
so
whole grains okay in low carb diet?
You can absolutely have plenty of vegetables on a low carb diet, just not starchy vegetables. Green vegetables are fine on a low carb diet. In fact, there was an article in BMJ Open back in 2018 that basically said that you can be on the ketogenic diet and get your requisite amount of fiber very easily if you just stick to green vegetables. Now, if you change colors, that might be an issue, especially if you go yellow or, white. So starchy vegetables, they're going to have carbohydrate. That's different. But there's nothing about a green vegetable that can't be included on a low carb or ketogenic diet.
Perfect. Are whole grains okay in low carb diet?
Yes, whole grains, as long as the grain hasn't been dispersed, as long as it hasn't been macerated, as long as it hasn't been pulverized. Now, think of it this way. Bread, okay? There's whole grain bread, and then there's whole grain bread. There's whole grain bread at Safeway, okay, where they started with whole grain and they took the mallet to it and pulverized it into a fine powder and mixed it with the flour and then baked it up. And they called it whole grain bread because they started with whole grains. But they macerated it so severely that that grain is not whole. All right? It looks like all the other bread, except maybe a little browner. That's not whole grain. They call it whole grain because they're allowed to, because the USDA doesn't have a definition of whole grain, but it's not whole grain. What is whole grain bread? What does it look like? So if you ever go to a very fancy upscale store like Whole Foods or Molly Stone's or, Zabar's or, wherever you live, you must have some gourmet grocery. And you go to the bread section, look for German fitness bread. Look for true whole grain bread. Now, this bread is half the width, okay? And it is stiff, okay? It's like a brick. If you threw it at somebody's head, you'd knock them out. If you took a regular loaf of bread and you threw it at somebody's head, it would bounce off and then they'd come and beat you up, okay? But if you throw a true whole grain bread loaf at somebody's head, you will knock them unconscious because it is so dense. They cut the slices very thin and there's not a lot of gluten holding it together. So it makes a terrible sandwich. It's a lousy sandwich, but that's whole grain because the grains have not been perturbed. The husk is still on the outside and the endosperm, the starch, is still on the inside where it belongs. And it takes a long time for the enzymes in your intestine to break that husk down in order to get the endosperm. By that time, that grain kernel is all the way through the intestine and the microbiome will chew it up instead of you, instead of it being absorbed early on in the duodenum like regular, processed bread. So bread's the example. Now, how can you tell if something is whole grain versus not? You have to, number one, feel it. Number two, you can look at the carbohydrate to fiber ratio. Normally, the husk is about 25% of the kernel, anywhere from 20 to 30%. So you look at the carbohydrate, and then you look at the fiber. And if it's greater than 5:1, that means it's been processed. So that's another way to tell. If it's 10:1, it's processed. If it's 8:1, it's processed. If it's 5:1, 4:1, then you have a chance on it actually being whole grain. That's
Awesome.
another one.
That's a helpful way to look at it. Great, thank you. Even healthy cereals have some sugar typically. Is any amount of sugar okay?
Yeah. So just like alcohol. So your liver has a limited capacity to metabolize alcohol, right? So 1 drink, fine. 2 drinks, depends. If you're a female, maybe not fine. If you're male, maybe fine. 3 drinks, you're getting a little tipsy. 4 drinks, you're becoming pretty, vocal. And 5 drinks, you're a friggin' alcoholic, right? It's a dose phenomenon. Well, turns out fructose and alcohol are metabolized in the mitochondria identically. There's no difference. And so in the same way there's a dose response effect to alcohol, there's a dose response effect to fructose, and it's about the same. So if you can keep your sugar content of your diet down below 25 grams a day, you'll probably be fine. If you go above 37.5, that would be like 2 drinks. Then you're starting to get into trouble. And 50 grams a day, you're already in trouble. And at 94, which is where the median of America is in terms of sugar, that's the same as being a chronic alcoholic. And that's why sugar causes non-alcoholic fatty liver disease, which is indistinguishable from alcoholic fatty liver disease, because the substrate may be different, but the process and the pathology is the same.
Okay. Is it possible to become addicted to junk food?
Absolutely. But it's the sugar that causes the addiction. The other stuff is in there to increase the salience of sugar. So the salt is there to increase the salience of sugar, like honey roasted peanuts. The fat is there to increase the salience of sugar, like a Cinnabon. Okay, I mean, which would you rather have, a Cinnabon or a pixie stick? Okay, the fat makes the sugar even more palatable. So not arguing that, but that's what ultra processed food is. That's the bliss point that Michael Moss in his book, Salt, Sugar, Fat, talked about, is how much fat, how much salt can we add to this sugar to make it addictive? To make it most addictive.
Yeah. What do you think about substitutions like monk fruit, stevia?
Right. Everybody wants to know about diet sweeteners. So in the last 2 years, the data has come in half as bad. Half as bad. So the toxicity of 1 Coca-Cola equals the toxicity of 2 diet Coca-Colas. Half as bad. Now, half as bad does not mean good. Half as bad means half as bad. Now, the problem is that if you think that diet sweeteners are the answer because, hey, no fructose, no calories, you'll drink 10 of them, in which case half as bad becomes 5 times as bad. So, in fact, we have just as much data for diet sweetener abuse and metabolic syndrome, and there are actually mechanisms by which diet sweeteners can cause metabolic syndrome, not because of fructose, but because of insulin and also because of changes in the microbiome and glucose intolerance and leaky gut.
So
that's not a great answer.
So I just wanted to make something clear. So in terms of anything, whether you're eating, so you suggest for men and women, no more than 25 grams of sugar per day.
That would be good.
Okay, great.
Added sugar. That's added sugar.
Added sugar.
Added sugar.
So that's not including eating banana per se, or the berries like you were talking about.
That's right.
There's fiber in
because there's fiber in those. Okay, great.
Right.
Just wanted to make it clear and make
that's
sure
right. You can eat all the fruit you want as long as it's whole fruit.
Okay, great. So you don't like smoothies?
Smoothies destroy the fiber.
I see. I told you already.
I know you already told me.
I've watched too many of your videos to know some of these answers.
I'm really sorry, Lisa.
That's great. That's great. No, it's good. We need to know this, you know?
I have a question because ice cream is Parkinson's favorite food. And so we joke about it all the time. And, you know, and some of the literature that we've been following, you know, talks about leaky gut from dairy.
Right.
Can you comment on dairy?
Dairy's complicated. I have a feeling that dairy affects different people in different ways. I mean, there's no question that some people do not do well with dairy. Other people do extraordinarily well with dairy. Dairy is a carrier for vitamin D, which is essential. You can't, we don't get enough of it. Dairy is a carrier vehicle for calcium and phosphorus, both of which we also don't get enough of. So I am in general for dairy. Now, there is this book out there called The China Study, written by Campbell and Esselstyn. I will just say one thing about it. It is 500 pages of univariate correlations. Now, what that means is that something's associated with something else. That doesn't necessarily mean causative. Mm-hmm. There are a lot of other things that could be going on in that study. And they didn't do any multivariate analysis to try to determine what was more important. And they certainly didn't do any time-dependent studies. And to prove causation, you have to have the component of time. They do not. So I do not think that the China study holds any water. Now, there are plenty of people who do, and we could have a debate about the veracity of the China study if you want to spend another hour. I do not give the China study any credence.
Okay.
I do have a question. There's a lot of people asking about specific things, raisins, different types of bread, all this. Is there something or somewhere people could go to research any of this stuff?
First of all, it's all on my website.
Great.
robertlustig.com. All of that is on my website. The book I wrote back in 2013, Fat Chance, has an entire section of which foods are which and which foods will be a problem and which ones won't. I think it's chapter 17 of Fat Chance. It's all in there. I did not repeat it in Metabolical because I didn't want to be guilty of self-plagiarism. But it's all there and it's all on the website. So, it's accessible. It's not like it's not. And other groups have published this as well. So this is not hard stuff to find.
Thank you.
Lisa, was your question answered about ice cream? Is it because it adds sugar?
Yeah, the sugar in ice cream is the problem, not because of the rest. The rest is fine.
So there was a question about repeating the website slowly. We put it in the chat. It's Robert Lustig.
Robert Lustig, one word, .com.
Yes, thank you. And then there are some questions. I'm not sure.
What effect does sugar have on astrocytes?
That's the astrocytes. That's where the glutamine synthase is. The astrocytes have the glutamine synthase, so it's inhibiting that in the enzyme in astrocytes that converts glutamate to GABA. Mm-hmm. And astrocytes, neurons, of course, have their own mitochondria, but astrocytes nourish the neurons with other stuff. And so if you're poisoning the astrocyte mitochondria with fructose, they're not going to nourish those neurons properly. And that may actually be one of the primary drivers of depression.
Mm-hmm.
Right.
Fantastic. Yeah, we talk a lot about astrocytes and exercise and for Parkinson's especially.
Agreed.
Yes. A lot of questions about Mediterranean diet, vegetarian diet, sugar-free
Mediterranean
ice cream.
diet's great. Mediterranean diet is terrific. Mediterranean diet has everything you need and nothing you don't. Okay, I'm a big fan of the Mediterranean diet. Now, just remember, the Mediterranean diet is not the Italian diet.
Uh-oh.
Oh, stop. You're just ripping my heart out of me.
Okay. The Mediterranean diet and the Italian diet are almost diametric opposites.
Yes, this is true.
Okay. Now,
it is true that peanut butter.
It is true that the Mediterranean diet was first, evaluated in Pioppi, Italy. That's true. Mm-hmm. But they don't eat in Pioppi like they do, at an Italian restaurant.
Right. It's true. So true. I didn't say eat at my restaurant. I didn't say that.
Here's a great question. How to increase mitochondrial function?
How does what?
How does one increase mitochondrial?
Wow. How do you increase mitochondrial function? Wow, what a good question. If we knew that, we could basically turn the clocks back. Obviously we all want to do that. There are some things you can do. The single best thing to increase mitochondrial function is exercise. Because what that does is that stimulates the sympathetic nervous system. Sympathetic nervous system stimulates PGC1 alpha, PPR gamma coactivator 1 alpha, which is the driver of mitochondrial biogenesis. So you make more and fresher mitochondria, which is very good. The Mediterranean diet has in it a very high level of a compound called spermidine. Spermidine is a polyamine that is necessary to induce autophagy. Now, autophagy is recycling of old defective parts of the cell, especially mitochondria, to get rid of them to make room for new, fresh mitochondria. So autophagy is essential and part and parcel of healthy aging. And so there are things in our diet and exercise, intermittent fasting, all of which increase autophagy. It's all in my book, Metabolical. I put that in chapter 8. And full disclosure, I am the chief medical officer of a company that is evaluating a supplement that we hope and expect will promote autophagy.
Cool. Incredible. So translation, diet and exercise. Well, I mean,
but not just any old diet and exercise.
Right.
Right.
Of course.
It has nothing to do with calories.
Absolutely.
And it's
Okay.
not just movement either.
Right. It's not just movement.
Very
Movement is good.
Yeah.
reduces cytokines. So kinesiology people have shown that movement reduces cytokine production, especially in patients with autoimmune disease. So any stretch is good. But if you want that autophagy effect, if you want that mitochondrial biogenesis effect, you have to generate a sympathetic nervous system response. So, it's complicated. There's a lot of stuff to it. But it's all the stuff we know. It's just, now we sort of know why.
Yes.
Right.
I love that, actually. The reason why I took the risk is a bit of a risk to ask you to come on. But, so many people that we work with and that we see have complaints of, the apathy, the depression, the anxiety, the lethargy, the lack of motivation. And I just wondered, what if it was this sugar? What if it was that alone? And how could they possibly venture into testing out if that had would make any difference? So with that in mind, do people go cold turkey or a slow way of reducing it?
Well, so if you're sugar addicted, and 20% of the population is, okay, and it's really easy to figure out if you're one of them. Have you ever said the following words? Oh, I have a horrible sweet tooth.
I gotta go. I'm out of here.
If you've ever said that phrase, you're a sugar addict,
Right.
till proven otherwise. Okay, and so if you go off sugar, and by the way, going off sugar often means going off caffeine, because a lot of people getting their sugar are getting it through sodas. But, well, maybe not you, but a lot of people are. Okay, so you're going to have both sugar withdrawal and caffeine withdrawal. So those first 5 to 7 days are going to be hell.
So you should isolate.
You have to be ready for it. So you can try weaning or you can try cold turkey, but you have to know that it's going to take about 2 weeks for those dopamine receptors to basically repopulate and for you to feel better again. And most people will have basically been recidivists if they don't know that it's coming and they don't know what to do about it.
Yeah. Yeah. And you had mentioned in another video about the kids that then, after you stopped feeding them the fructose that they wanted to play, sports again and
Right.
those different things.
Amazing.
They felt more energized. They
Absolutely.
didn't feel as slothy. Now, we didn't, unfortunately, do an analysis. We would like to have done that. In retrospect, we would do that. Do an analysis of mitochondrial function, pre and post. But other people have looked at that, and there's definitely an effect of getting rid of the sugar. You feel better.
Yeah.
And my colleague Bill Wilson knows it for sure. That's what he does.
Yeah, that carb syndrome, that is really incredible.
Yes. So, there's so many different questions about, what about small amounts of sugar and all this? And you pretty much answered, no more than 25 grams of sugar
Per day.
Per day,
Right.
if you can, for men and women.
And for kids, 12 grams, and for toddlers under 2, 0 grams.
Good to know. Yes, absolutely.
0.
Great. Well, we really appreciate you taking your time out of your day to meet with us. Thank you so much. Not everyone wants to hear this information, but we're so happy that we had you come on and tell us about this, because it is so important to how our community is living with Parkinson's. And for those of us who aren't, it's so important. I'm a sweet tooth, and I'm the first to say it. So makes me think twice about what I'm having for my lunch later.
And it's not always the medications. A lot of times people feel bad from day to day, but nothing's changed except
what they're eating.
Maybe.
Mm-hmm.
So, all right. Well, we appreciate you so much and all the wonderful work that you're doing.
For those of you who don't know who we are, you can add a little spotlight for us maybe. I'm Steph, and that's Lisa, and we already said that we're PD Connect, but we teach exercise and education to people with Parkinson's virtually and in person. So check us out at pd-connect.org and come join us in a class.
And we have support groups, and we will support you through your sugar cold turkey detox if you choose to do it that way.
Maybe I need you to support me and my sugar.
We'll try it on you first.
Yes, let's try it. Well, take the challenge with me. Let's eat no sugar, people, or very limited amounts of sugar. Thank you so much, Dr. Lustig. Have a great afternoon.
And
thank you, everyone, for joining us.
Thank you, Doctor.
Thank you.
Thank you. Thanks for having me.
Absolutely.
Thank you.
Bye-bye.
Dr. Lustig said, to test out if it's real bread, you've got to toss it against your head. Ow!
Yeah, that's painful.
That's real bread.
That's real bread.